Hello, am I audible?
Yes, sir. Good morning.
Yeah. Okay, so we'll start the session now. Let me share my screen. Okay, so basically I'll solve a few questions which are in some sense which are important for your exam point of view. Okay, so yeah. Okay, so the first one is basically you have a relation. Okay, so you have a relation which is basically defined on this set A. So A is basically 1 to 8. And what is your relation? Relation is basically it's set up all pairs x comma y such that y is a divisible y is divisible by x. So you have this relation on this set A. Okay, and what you need to check whether that relation satisfy all this property or no. Okay, so can one of you tell me what is this set R? What is this set R?
This should be transitive because we will have 1, 1, 2, 2, 3, 3. This number can divide by itself. Correct?
That is certainly correct, but I want to know what are the elements of R? All the elements of R.
Okay, so 1, 1, 2, 2, 3, 3 will be there. The number can divide by itself.
1, 1. Okay. So then see 1, 1 should be there. 1, 2 also should be there, right?
Correct.
3, 6.
And all numbers are divisible by 1. So yeah, that is correct.
Yeah, this is also
1, 4, 1,
1, 5,
5,
1, 6, 1, 7, 1, 8.
7 and 1. Okay, so basically these are the pair that starts with 1. Okay, so next you consider all the pairs that starts with 2. Okay, so you take 2,
Okay.
then certainly you
Four.
can't.
2 can be there. 2, 2
Yeah,
also.
yeah, correct. 2, 2, then 2, 4.
2, 6.
2, 6,
2, 8.
2, 8.
Okay, so the next one is I'll start
3,
with 3, 3, 3,
3, 6.
3, 6, right?
Yeah.
Mm,
Then we have
then
4,
4,
4,
4,
4, 8.
4, 8, then
5,
5,
6, 7, 7, 8, 8.
5, 6, 6, 7, 7, 8, 8, right?
Yeah.
So this is my set R. Okay, so I just need to check whether R satisfies. So what are the options that I can say that R satisfy that property? Okay, so first let me start with reflexive. Whether this relation is reflexive.
Yes, sir. And we are missing the 4, 4 elements. Sir.
Yeah, correct.
And this is a reflexive relation.
Yeah. So as you can see, this A comma A. So for reflexive, what you need to check? This A comma A is in R for all A in A, right? That is the property that you should check to say that this relation R is reflexive, right? So it's clear, right? This 1 comma 1 is there. Okay, 2, 2 is there, 3, 3 is there, 4, 4 is there, 5, 5 is there, 6, 6, 7, 7, 8, 8 are there, right? So this condition holds for all A in A. So that's why this relation R is reflexive. Is it clear?
Yes, sir.
So what about symmetry? Whether this relation is symmetry? What is the definition
No.
of symmetry relation?
A comma
If
B
B is there, then B, A also should be there.
Okay, if A comma B is in R, this should imply that B comma A is also in R, right? That is the symmetry condition. So can I say that whether this relation is reflexive?
No.
Correct.
not symmetric.
Symmetric. It cannot be symmetric.
Yeah. So basically, you can actually, it's more or less you can say that in generally, if you see a tuple A comma B where y is divisible by x, that doesn't imply that x is also divisible by y.
Correct.
Because if you let's say you pick this pair 1, 2, right? You pick this pair 1, 2. As you can see, 1, 2 is in R. Okay, but 2, 1 is not in R, right? So that's why R is not symmetric. Okay, R is not symmetric. Not symmetric relation. So the next one is transitive. Whether R is transitive.
Yes.
Yes.
Yeah, transitive.
Okay, so for transitive, what I need to show?
A comma B is in R and B comma C is in R, then A comma C also has to be in R.
If A comma B is in R, B comma C is in R, this should imply that A comma C is in R. So how I can show that this relation is transitive? So in particular, how I can show that our relation R satisfy this condition?
Say 1, 2 is there and 2, 4 is there, and we also have 1, 4.
Yeah, but again, like so if see the thing is, as you can see, there are lot of elements, right? So if you start checking one by one, then it's going to be a very tedious task. Okay,
Correct.
so can you show it in general by simply by using this using this definition?
If a number is divisible by, if y is divisible by x and x is divisible by some other number, then y has to be divisible by that number as well.
Yes. So
Yeah,
basically,
Y is divisible by X and Z is divisible by Y, then Z is divisible by X also.
yes. So you have A comma B, which is in R, right? So by definition, B is divisible by A, right? This is by definition, right?
Yeah.
And this implies that C is divisible by B, right? So from these two statements, what we can get? A divides B, right? And B divides C, right? So that means A also divides C. C is a multiple of B, B is a multiple of A. That means C is also a multiple of A, right? So that means I can, by using these two things, I can say that A also divides C. That means A comma C is also inside my relation. Okay. So from now I can say that my relation is transitive, right? So now I can say that this R is reflexive, but R is not symmetry. R is transitive. And what about whether R can be equivalence relation?
No, sir.
No,
Yes.
because it's not symmetric.
Because it's not symmetry. So when I can say that a relation is a equivalence relation if R is both. So if R is reflexive, symmetry, and as well as transitive. Okay. So in our case, R is reflexive, transitive, but R is not symmetry. So that's why R is not a equivalence relation. Okay. So is it clear now? Is there any doubt from question number 1?
No, sir.
Okay, fine. Okay. Let me move to the next question. So next question is basically what you have a map, and so in some sense, so as you can see, this is a map from the set of all natural number, okay, n, to the set of all natural number n. So here domain and codomain both are set of natural number. Okay, so that is so f is a map from n to n. So and it is defined like this. So f of n is n plus 1 by 2 if n is a odd integer. Sorry, odd natural number, and f of n is n by 2 if n is even. Okay, so now you need to check whether f is 1 1 or on or 1 1 or on. So any guess?
It's definitely not 1 1 because if you take x to be x to be an odd number and x plus 1 to be an even number, then both of them will have the same value.
For example, do you have any specific example?
5 and 6, both of them will give you 3.
Correct, absolutely. Yeah. And what about
It is on to, sir.
it is on to why?
We will map to every pre-image will have its image.
Yes, so yeah, you are in some sense you are correct, but can you give a proper explanation?
Sir,
How?
like one will have 2 pre-images, 1 and 2, and 2 will have 3 and 4. Like this, every number will have its pre-image.
Yes, correct. So basically we don't need 2 pre-images. We basically need only 1 pre-images, right? So as someone already said, okay, let me start with first whether this function is 1 1 or not. So one can easily show that this function is not 1 1. Okay, so this is not 1 1 because if you take f of 1, then this is, so 1 is odd, then this is 1 plus 1 by 2, which is 1. Okay, so the image of 1 is 1. And next, what you do, you compute f of 2. F of 2, so 2 is odd, so the image should be 2 by 2. Sorry, 2 is even, the image should be 2 by 2, which is 1. So 1 maps to 1 and 2 also maps to 1. So we have two different things in our domain, and both are the image of both the elements is 1. So that from here itself we can say that f is not 1. Okay. And the next thing is what we need to show whether this function is onto or not. And already someone gave the answer. So what we need to show to show that this function is onto, we need to show that every element in the codomain, okay, every element in the codomain has a pre-image in the domain, right? So every element in the codomain has a pre-image in the domain. Okay, so for that, what we can say, you take this number, let's say alpha. Okay, you pick this number alpha in the codomain. Then alpha has a pre-image which is 2 alpha in the domain. Okay, so for example, if I pick 1, then the pre-image of 1 is 2, right? And pre-image of 2 is 4. Pre-image of 3. So basically, in particular, what I can say, 1 has a pre-image, 2 has a pre-image, 3 has a pre-image. So all the elements, even 0 has a pre-image, that is 0. Okay. So all the elements in my codomain has a pre-image in the domain. So that is precisely the condition of onto. So now I can say that F is onto, right?
Yes. But
Yes.
sir, like in the n term, we are not considering 0 as the natural number.
No, not in n term. Actually, for calculus part, actually you have to ignore the natural number.
So like only for calculus, we are not considering 0 as natural, and other than that, we have to consider 0.
Yes. For the calculus week, you don't have to consider 0 as a natural. Okay. Any doubt from question number 2? Okay, fine. Okay, so let me move to the next question. So, okay, so is there anything else you want me to discuss from week 1? Okay, so okay, so you can keep your question. So we'll discuss what, if you have any doubt, we'll discuss in the end. Okay. Okay, so the next question is basically the next question is you need to find the best fit. So for this line with respect to this given data. So in other words, you need to find the SSE of this sum square error of this line with respect to this given data. So can one of you tell me how I should compute the SSE? What is the formula for this SSE?
Sir, the actual value of the y minus predicted value.
Correct.
Whole
Correct. So this is basically what? So okay, so this is my x1, this is my y1, right? This is x2, this is y2, this is x3, y3, x4, y4, and x5, y5, right? So these are the given inputs. Okay, so the SSE is basically what? This is, so I have precisely 5 set of points. So the SSE is yi, okay, minus xi plus 1 whole square, where I varies over 1 to 5. So as you can see, this part is precisely coming from the equation of this line. So what I am doing here, so in the left right hand side, I am basically substituting this xi plus 1. Okay, so now can you tell me what is this thing, this total sum?
10.
9.
Sorry, if I substitute 1, so in our first case, x1 is 1, y1 is also 1, right? So for x, so then what I will get? 1 minus
2.
Yes, correct. So 1 minus 2, which is precisely 1,
1.
right? So this is 1
Square.
minus 1 square. So in the end, I will get 1, right? So the next one is what?
4.
Yes. So next one is, this is 1 minus 3, and this is minus 2. And if I take the square, then I will get 4, right? Then what about the third one? This is again
4.
4, correct.
4.
And the fourth one is, I guess, is again 4, right?
No.
0.
0, sir.
Last one is 0.
Okay.
The
So this is
last one is
5 minus 4 plus 1. Okay. Yeah, this is 0. And what about the last one? Last one is also, I guess, 6 plus, 0. Right? So the final thing is basically 9.
9.
Okay. So the SSE of sum square error of this function. Okay. So here the function is nothing but it's a straight line. Okay. With respect to this given data is 9. Okay. So this is how you should find the sum square error. So in some case, actually, you may see you may get some different function instead of this straight line. You may get some maybe some logarithm function, or some quadratic function, or cubic polynomial. So you can actually use this method. Okay. So there is nothing special about this this line. Okay. So let's move to the next question.
Sir, one question here. So, is there any further application after finding out the SSE? So, this 9 we get. After that, say if there are 2 or 3 things are given, whichever has the lowest sum square is the relevant answer, something like that.
Yes.
Is there any other application of SSE?
In what sense, actually? So application in the sense what?
No, can we get any other questions after deriving SSE? Can we get some other question on top of that? Is what I'm saying.
See, many times. So many times you may not get this data, right? You may not. So if you I guess you must have seen a few questions. So suppose it is given that the SSE is the expression for the SSE is, let's say, minus 4a square plus 6a plus 2, right? So suppose you don't have any data, and for with respect to, okay, so suppose the question is something like, so you have a function, okay, and with respect to few data, okay, which are not basically not mentioned in the question. With respect to few data, the SSE is this, right?
Okay.
So then basically you need to find the value of a. Okay. So you need to find
Even if the sum of the y values are not given, we have to find from that.
No, SSE is given. Yes. So as I said, with respect to some data and with respect to some function, the SSE is something like this. Then you need to find the value of a. So you know that this SSE has to be minimum, right?
Yes, correct.
So now you need to find the value of a for which this thing will give you the minimum. Okay. So now this is a parabola, right?
Yes, sir. But sir, we are having a negative coefficient, so this parabola will give us the max values. Isn't it?
Okay, sorry. It's my bad. Yeah.
Yes, sir. Now we can find the vertex and at the vertex.
Yes. So now you need to find so now you have to find a value of a which will give you the minimum value for this parabola. So precisely it will give you at this point, right? A equal to this by this, right? So at this point, this SSC is precisely will give you the minimum value. So this also, like you must have seen this type of question, right?
Yes, sir. Yes.
Yes.
And in some cases, actually you may see some different functions. So some function like y equal to x cube plus, let's say, 2x square plus 7x plus 1. Okay. So you need to find this y, this. So then this express whatever this expression will be slightly different. Okay. So in that case, you will have something like this, right? yi minus xi whole cube, right? I just need to substitute this xi over here. Xi whole cube plus 2. Okay, so this should be 2x square. So this is 2xi plus 2xi whole square plus 7xi plus 1. Okay. So you will get an expression like this. Okay, instead of an expression like this, you will get some new expression. So it's depend on the function. What function is given in the question. Okay. Okay, anything else?
No, sir.
Okay, fine. Okay, so let me move to the next question. Okay, so you have a parabola, right? You have some parabola p of x, which is precisely this x cube minus 8x plus 15. Okay, so can one of you tell me whether this parabola is opening upward or downward by just looking at the equation?
Upward.
Upward.
Yes. So as you can see,
not
yes.
negative.
So the coefficient of x square, it's not it's precisely positive. So once this coefficient is positive, then this parabola is opening upward. Okay, so the first thing what we need to do, we need to find the x-intercept and y-intercept of this parabola. Okay, first so then okay, so let me first so how we can find the y-intercept of this parabola?
X is equal to 0.
Yeah, so precisely this point. So y-intercept is mean basically the point at which this parabola cuts the y-axis, right? And in this point, the x coordinate is 0, right? And in this point, this x coordinate is 0. So to get this point, I have to substitute x equal to 0. So for that, I need to find p of 0, right? So what is p of 0?
15.
It's 15, right? So once this is 15, then I can say that the y-intercept of this parabola is precisely this point. This point is nothing but 0, 15, right? So my y-intercept is 0, 15. And then what about the x-intercepts?
3.
Sorry?
3 and 5.
Yeah, so to get the x-intercept, what actually we need to do? So x-intercept is precisely all the points.
P of x is equal to 0.
Yes, so
Find roots of it.
So these are the points where this y coordinate is 0, right? So x-intercept is basically all the points where the y coordinate is 0. That means this p of x is 0. So if p of x is 0, then what we have? We have x square minus 8x plus 15, which is 0. So from here we need to find the values of x. So for that we need to factorize. So what will be this factorization of this quadratic polynomial?
X minus 5 into x minus 3 equals to 0. Minus 3x, yes, sir. Yes, sir.
X minus 3, right?
Yes, sir.
Equal to 0. So from here I can actually easily get. So my 5, 0 and 3, 0. Okay. So these are the x intercepts. Okay. So the next thing is the vertex and the axis of symmetry. Okay. So what is the vertex of this parabola? What is
4.
4.
Axis of symmetry, x is equal to 4.
No, I'm asking about the vertex.
4, sir. Minus b by 2a.
No.
4
what is
comma
the-
minus 1.
-1.
Yeah.
4 comma 15.
So first, actually, what you need to find? Okay, see
4
the
comma
vertex
minus
is a
1.
point, right? So first we need to find the x coordinate of the vertex, right? So that is precisely minus b by 2a. So if you find this, then what you will get 8 by 2. 8 by 2, right? 4. And so once you have this x coordinate, you need to find the y coordinate as well. That is what is f of 4 here? 1, right?
Minus 1.
-1.
Minus. Okay. So from here you can say that this is the vertex. Then what will be the axis of symmetry?
X is equal to 4.
Correct. So this line x equal to 4 is precisely your axis of symmetry, right? Then you need to find the maximum or minimum value
Minus
the,
1, which is minimum value. Minus 1.
yeah. So you know that this parabola
The minimum value.
attends its minimum value at the, so since this is a parabola which is opening upward, so it will attain its minimum value at this point x equal to 4, and you know that the minimum value at 4 is, sorry, the value of the parabola at 4 is -1. So the minimum value is -1. Okay. So the next one is, what will be the slope of this parabola at this point 3, y?
-2.
-2. Yeah, correct. So the slope of this parabola is precisely what? This is, you need to take 2x minus 8, right? 2x minus 8. So we want to find the slope of the parabola at this point 3, y, right? And once we substitute 3 here, what we will get? We'll get 6 minus 8, which is -2. Okay, so
Yes.
so let me add one more question. So suppose you treat this parabola as a function. So you treat this parabola as a function from R to R. So x goes to x square minus 8x plus 15, right? So what is the range of this parabola?
X square minus 8x.
Minus 1 to infinity.
Sorry?
-1 to infinity.
Yeah, correct. But why? Can you tell me why?
The minimum value of the function is -1.
Yes. So okay. So whatever he said is correct. So you have this parabola, right?
Yes, sir.
So this value, so where this parabola attains its minimum value, this is 4 comma minus 1, right? This point is 4 comma minus 1. So that means this point is minus 1 comma, sorry, this point is 0 comma minus 1. So as you can see, all the points which lies above this point, that means all the points in this line which are above this 0 comma minus 1 is precisely in the range of this parabola. Okay, so the range of this parabola is minus 1 comma infinity. Okay, so this is the range of this parabola. Okay, any doubt? Okay.
Yes, sir. One doubt. Hello.
Yes, please.
Sir, what is the formula to find slope of this? Is it 2ax plus b or minus b?
It's
Yes.
depend. It's 2ax plus b. So see, if your parabola is of this form, ax square plus bx plus c, then the slope is 2ax plus b.
If b is minus, if b is negative, then we will put minus.
See, b certainly depends. So b is any real number. So it's depend on the sign of b. Yeah. So if
Basically,
is,
we are finding derivative of this equation.
correct. We are precisely taking the derivative of this this polynomial. Okay.
Thank you, sir.
So, how you have computed that minimum value? Formula of minimum value.
Sorry.
So, how to find minimum value?
No, minimum. Okay, so you are asking
Yes, sir.
the proof or like.
Sir, how you have concluded this?
So you know that this the minimum value, this parabola attains its minimum value at the x coordinate of the vertex, right?
Yes, sir.
So what is your vertex? So vertex is what? This point, right?
Yes, sir.
So as I said, the parabola attains its minimum value at the x coordinate of the vertex. So what is the x coordinate of the vertex? This is 4, right? And it attains its minimum value at x equal to 4. So you just need to compute f of 4. Okay. So f of 4 will be the minimum value. So if you substitute f of 4, if you substitute 4 in the equation, then you will get minus 1.
Okay, sir.
Yeah. Okay. Okay. So next, let's move to these questions. Okay. So you have two polynomials. Okay. So you have these two polynomials. Okay. So by drawing these two polynomials, you need to find the number of turning points. Okay. So first, what you need to do? So your target is basically to find the number of turning points of this polynomial and as well as for this polynomial. Okay. So first, what you need to do? You need to draw the polynomial. Okay. So any idea how I should proceed for
First,
option?
we need to find the degree of polynomial.
Okay, correct. So what is?
And say coefficient.
Okay, so let me denote this polynomial as p of x. Okay.
Degree of p of x is 9. Yes.
Yeah. So this is 2, 3, 5, 6, 7, 9. Yeah.
Sir, and we have to take minus outside, I think.
Yeah, I'll come to that. Yeah, you are correct in some sense. Okay, so once we have degree, then what we need to find? We need to find, okay, so in some sense, you it's enough for you to find the leading term of this polynomial. So what will be the leading term of this polynomial?
1, sir.
What leading term is?
-1.
-1.
No, sir,
Minus
it's
1.
1. Sir, how? Sir, how, sir?
Okay, please please mute yourself. I'm getting some noise. Yeah.
Will be the leading term.
Yeah, so we want to find the leading term. Okay, so I can rewrite this polynomial as x plus 1 whole square x minus 2. Okay, so I can rewrite this polynomial as p of x, which is x plus 1 whole square x minus 2 x plus 3 whole square, then x plus 4. So instead of this 5 minus x, what I will write now, I'll write x minus 5, and I will have a minus sign in the beginning. Okay, and then x minus 6 whole square, right?
Yes, sir, got it. Yes. Okay, sir.
So then what will be the leading term of this polynomial?
-1.
Minus.
Yes.
Minus
1.
Minus a.
Oh, sir.
minus x power 9, right? This
Yes.
is the leading term. So -1 is basically the coefficient of this x power 9. Okay, so the leading term is precisely this minus x power 9. Okay, this is the leading term. Okay,
Okay, sir.
so again, let me tell you. So you need two things. Okay, you need two things to draw a graph of a polynomial. So the first thing what you need basically you need the end behavior. Okay, so first thing you need the end behavior, and second thing you need the roots of the polynomial. So here the roots of the polynomials are already given. So by just looking at the polynomial, you can get all the roots. So the next thing is you need to find the end behavior. Okay, and to get the end, to get a idea about the end behavior of the polynomial, you need to know the leading term. So now can you tell me what? Tell me about the end behavior of this polynomial.
Like minus x cubed graph.
Sorry.
As x tends to infinity, the function value tends to minus infinity.
Correct. So as x tends to plus infinity, okay, so from here you can say that this minus x power 9 tends to minus infinity. Right, and this end behavior of this polynomial, okay, this end behavior of this polynomial is completely depends on the end behavior of its leading coefficient. Okay, since this minus x power 9 is also going towards minus infinity, that means my p of x will also go towards minus infinity, right? So
sir, if we will put, sir, one thing, sir. So if we will put a negative value in this, then it will go to no, sir. Yes, sir. If we will put a negative value to this polynomial, then it will go to infinity plus infinity.
Yeah, that is correct. But now we are taking only the positive infinity, right?
Okay.
So So this part is, this is correct, right?
Yes.
This is correct. So what you are saying, so you are saying something different. As x goes to minus infinity, right? In that case, x power 9 will go towards
Infinite.
plus infinity, right? And then p of x will go towards also plus infinity,
Plus
right?
infinity. Yes, sir.
So again, like, see, the thing is, it's depend. So you need end behavior of the polynomial in one side. Okay. So if you know in a single side, okay, that is enough for you to draw the polynomial. Okay. So in particular, either you need to know this thing, right, or you need to know this thing. Okay. If you know one of these two things, then you can draw the polynomial, right? So either you can compute this second one, or you can compute this first one. It doesn't matter which one you are computing. Okay. So the next thing is you need to find the roots of the polynomial. Okay. So can one of you tell me what are the roots of this polynomial?
-4,
Minus
-3,
one,
-1,
-3, -4, -5, and 6.
Correct. So this is -1, -4, -3, okay, then 2, 5, 6, right? So I have precisely what, 6 roots, right?
6 roots.
And one more thing you need. So to draw the polynomial, you also need to know the multiplicity of all the roots, right? So what is the multiplicity of -1?
Sir, 2.
2, sir.
So as you can see, so -1 is basically coming from this factor, right? -1 is coming from this factor, and you can see this this power of this factor is 2. So this power is precisely the multiplicity of -1. So the multiplicity of -1 is 2, and multiplicity of -4 is what? It's 1. Multiplicity of -3 is 2.
2.
Multiplicity of 2 is
1.
1.
1.
And it's
2.
2, right? So now I have all the information to draw the polynomial. Okay. So so I know these are, so what I know basically, these are all the roots of the polynomial. So roots is precisely basically the roots will give you all the x-intercept of the polynomials, right? So this is what? This is -1, 0. This is -3, 0, and this is -4, 0, and let's say this is 2, 0, this is 5, 0, and this is 6, 0, right? So this is, so these are the x-intercepts of the polynomial. So now then what should I do next? So what will be my next step?
You have to draw the end behavior first.
So I need to draw the graph using the end behavior, right? So it's given. So again, like, you can use any one of these two things. Okay. So let me pick this one. Also, you can pick the below one as well. Okay. So it's basically says, as x tends to plus infinity, this p of x is going towards -infinity, right? So then from which direction this graph of this polynomial should come to 6, 0? Yeah.
So from below.
Below.
Yeah. So because it should come from the below, right? Because it's saying as x tends to this plus infinity, my p of x is going towards minus infinity, right? So if this graph will come from above, right? If this graph will come from above, that basically means that p of x is going towards plus infinity, right? And if this graph comes from the down, this precisely means that this p of x is going towards minus infinity. But we are basically in this situation. This p of x is going towards minus infinity. So that's why this can't happen. Oh, this graph can't come from the above. It has to come from the below of this x-axis. Okay. So first it will come from the below to this point 6, right? So the next thing is, so now you have,
It will bounce back.
yeah. So now you have two possible cases. So either this graph can come to this 6, 0, and then it can bounce back, okay? Or one more thing can happen. It can cross this point, and it can go to the above of x-axis. So now you have two possible cases, and this thing is controlled by the multiplicity of the root. Okay, if the multiplicity of the root is even, then it will bounce back. Okay, if the multiplicity of the root is odd, then it will cross the x-axis. So what is the multiplicity of 6 here?
2.
2.
And it bounced back.
Correct. So since the multiplicity of 6 is 2, then it will bounce back. Okay. Multiplicity of 6 is 2, then it will come like this. Okay. So again, it has to go towards this 5, 0. So it will come like this, and again it will go to this 5, 0. So then next, what will happen? Whether it will cross. It will definitely cross, because the multiplicity of 5 is 1, which is odd. Okay. So it will cross this 5, 0. Then again it has to come back to this point 2, and at 2, as you can see, the multiplicity of 2 is what? It's 1, right?
Yes, sir.
So again, it will cross this point, right? So again, it will go to this point minus 1, 0. And what is the multiplicity of minus 1?
It will bounce. It will bounce.
2.
2, right? So again, it will bounce back.
Bounce back.
And again, it has to go towards
minus
3.
It will bounce back.
Again, it will bounce back. Okay. And then it has to go towards.
It will cross, sir.
Yes, correct. Okay, so this is precisely the okay. This is the rough diagram for this polynomial p of x. Okay, so as basically you can see the graph of this polynomial is completely dependent of this end behavior, and as well as from the roots of the polynomial. So now, so once you have this graph, now can you tell me, wow, so what is the number of turning points for this polynomial?
8 turning points, sir.
8
turning points.
8, sir.
So this is 1, this is 2, this is 3, this one is 4, and this one is 5, 6, 7, 8, right?
So
So
one question, sir.
Hmm.
Sir, if on 5, 0, if the multiplicity is 3, then what will be the turning point, sir?
Same number of turning points. So see, if the multiplicity is 3, it doesn't matter. It will cross this x-axis. Okay.
Because the graph will be different, sir.
No, the graph will be different, but again, certainly it's not going to affect the number of turning points. Okay, so as you can see, the graph will be something like this. So let's say this is your, let's say this point is your 5, 0. Okay, so your graph will be something like this. Okay,
because it's turning, so that's why, sir, I asked.
No. It's certainly this in some sense this at that point actually. So at that point actually you don't have that in some sense what I can say. So in that point you don't have this situation, right? You don't have something like this, right?
Okay, sir. Oh,
direction is not changing.
So actually there is some certain different word you use, like so,
Like the saddle point, right, sir?
So, yeah.
So I got it. So can you explain, sir, end behavior briefly, sir? I understood the whole question, sir. Can you briefly explain end behavior?
So can I know your name, like
Parth.
Okay, so Parth, actually let me explain you this second option as well. Okay,
sir.
So after that, if you still have any problem, like I can spend more time. Okay, no. So let me. So this question is clear to you, right?
Yes, sir. Clear.
Yeah. So let me solve the next one. So
one small question. If we have x plus 1 whole to the power of -1.
Sorry.
So in the same question, if we take the first term, it's x plus 1 whole square, right?
X plus 1 whole square. Here we have whole square. Yeah.
In that case, if I take x plus 1 whole to the power of -2, then how do we have to deal with that?
X plus 1 power of -2.
Yes.
Yeah, then it will be difficult. Then this is not a polynomial, right?
It will be a polynomial.
No, you in polynomial you can't.
1 by x plus 1 whole square.
Rational numbers are not allowed.
You can't have negative power, right? Then it's a rational function. See, when you are taking x plus 1 power -2, okay, then you have negative power, right?
Yes.
So then this is not a polynomial, right?
But if we divide the whole thing with x plus 1 whole square,
but that is not the definition of polynomial. So do you think this is a polynomial? 1 by x? This is x inverse, right?
Yes.
Then this, so according to your definition, this is also a polynomial. This should be a polynomial, right?
Yeah.
Then why it is not? Then why you are saying this is not a polynomial?
Okay.
So when you are taking the negative sign, actually, then in that case, it's not a polynomial. See, the polynomial, the domain of the polynomial is what? Its polynomial is basically it's a function from R to R. Okay, so when you are actually saying, when you are dividing this whole expression by, so then you have something over here in the numerator, and you have something here in the, so the denominator will be 1 x plus 1 minus 2. Now this p of x is not a function from R to R, because at -1 this p of x is not defined. Okay, so polynomial, so by the definition of polynomial, you can't take this negative power.
Sir, I have one question.
Yes,
so this is about the maximum number and minimum number of turning points. I think maximum is pretty straightforward. It is max number of degrees by -1. But minimum, how do we find, sir?
No, minimum actually it's completely depend on the polynomial. Okay, so this maximum actually you can basically you can guess by the degree. Okay, so for example, I can take a degree 9 polynomial. Okay. With no turning points, right? So I can take a degree 9 polynomial with no turning points. Okay. So for example, you take P of x equal to x power 9. Okay. So in that case, actually, you will have 0 turning points. Okay. So this minimum number you can't guess by just looking at the degree of the polynomial.
Yes, sir. Because I think one of the question papers we had a question like at least these many turning points, and the statement we have to say true or false.
No, that's as I said, right? That depends on the polynomial. Like if some polynomial is mentioned or something like this, then I can say about the minimum number of turning points. See, if you simply say that what will be the minimum number of turning points for a degree 9 polynomial, okay, then the answer is 0, right? 0 is also a possible answer, right? And if you have a even degree polynomial, okay, so in that case, so the minimum will be 1. Okay, so it's depend on the polynomial. Like if you give me some specific example of polynomial, then
okay, sir. Okay, thank
yeah.
you.
Okay, fine. Okay, please. Okay, someone is asking, can we discuss the case of imaginary roots? I didn't understand that. Can you just briefly explain what you were asking?
Yes, sir. Sir, actually, there was a case in the lecture where sir discusses the point which you mentioned. There may be a degree 9 polynomial without any.
Sorry. Please. Can you say it little clearly and slowly?
Yes, sir. So there was a case which was discussed in a class. Like you said, there may be a degree 9 polynomial without any turning points, and then it turned
Without
out
any
that,
real roots.
yes, sir.
Yes,
Sir,
yes. No, you can't have. You can't have a degree 9 polynomial without any real root. Yeah.
Sir, is it possible to have a degree 9 polynomial without any real roots?
No, it can't. It is not possible. For a odd degree polynomial, it is not possible. For even degree polynomial, it is possible. See, these imaginary roots comes in a pair. Okay. Comes in a pair. Right. So that means if all the roots of a polynomial polynomial are imaginary, then the degree of the polynomial has to be even. Okay. So
at least one.
It's even. So see, the problem is basically this imaginary root comes with a pair. Okay. So I'm getting some noise. Okay. Nisha Chauhan. Yeah. So the thing is, what basically I'm trying to say, if a plus ib is a root of a polynomial, then a minus ib is also a root of that polynomial, right? That is what I am trying to say. So this imaginary roots, they comes with a pair, right? So what basically you are trying, so what you are saying that is it possible for a degree odd polynomial such that all the roots of the polynomials are imaginary? That is not possible, because see, suppose you take a degree 3, right? So this has 3 roots. So one is a plus ib, then next one is a minus ib, because as I said, this imaginary roots, they comes with a pair. If this is a root, then this has to be, and then you have something else. If this is also imaginary, then it should come with its conjugate, right? It should come with its conjugate. So if it will come with conjugate, then certainly it can't be a degree 3 polynomial. It has to be a degree 4 polynomial. So the third one has to be real. real.
Thank you, sir. Thank you, sir. That is clear now. So that means the one next to the odd degree polynomial will have at least one real root.
Yes, yes.
Thank you.
Any other doubt you have?
We can proceed, sir.
Yeah. Okay, so let me take the next polynomial. Let's say this, and then the next one is, let's say, q of x. So what is this q of x? So this q of x is minus, just a minute. Take a photo so that I can write it here. So q of x is nothing but minus 2 times x plus 1 whole square, x minus 2, x plus 3, x plus 4. So, okay, so now I have this polynomial. So the first thing what I should do, I should find the end behavior of the polynomial. And to get the end behavior of the polynomial, I need to know the leading.
It's plus x to the power 11.
Sorry?
Plus x to the power 11, sir.
Plus,
is it?
Plus x to the power 11, you are saying?
Yes, sir. Is it?
Why? Why?
Sir, because if we see minus 2, sir, we will multiply minus 2 to x minus 2. It's a root in this polynomial. So we will multiply this. Then we will get a. Sorry, sir. Minus x to the power 11.
Minus
2 to the
x to the
power
2x to the power 11.
Correct.
So we will multiply in it, na? To the root x minus 2.
Sorry, no, see, the thing is, okay, so what actually you are doing, you are actually making see, the thing is, if you see this question, so how actually, so for this case, how we got this minus x power 9 as the leading term of this polynomial. See, from this expression, okay, we are getting x square. Okay, from here we are getting x. From here we are getting x square. From this term we are getting x. From here we are getting x, and from here we are getting x square. And we have a minus sign here. This is minus, right? Only minus 1. So this is precisely nothing but it's minus 1. So we are actually multiplying all these things. And if you multiply all these things, then in the end you will get minus x power 9, right? So again, now if you see this particular polynomial, you have minus 2 here, right? And from here you will get x square. Again from here x, x square, and x square. So now if you multiply all these things, then what you will get?
Minus 2 to the power minus 2x to the power 11.
Correct. Okay. So this is the leading term of this polynomial.
No, sir. I was saying that if we will multiply minus 2 to x minus 2, then we will get minus
4 minus x.
No, 2 minus 2 to x minus 2. It's a root in polynomial x minus 2.
So if you multiply minus 2 to x minus 2, right? That is what you are saying, right?
Yes, sir.
So then what you will get?
So we will get
4 minus 2x, right?
Yes, sir.
So then?
So we minus will be out of this. So we will get 2x minus 4.
2x minus 4.
Yes, sir.
Yeah.
And it is also a root, sir. We will get we can. Oh, sir. Sorry, sir. Yes, sir. We can take common.
If you take
Yes,
so
sir.
then,
Sir.
so
Yes, sir.
so if you take this 2x minus 4 from here, you can pick 2x, right?
Sir, of course, sir.
So
Sorry,
in
sir.
the end, you will get the same thing. Okay, it doesn't matter what you are doing.
Okay.
Okay, so this is the leading term of this polynomial. Now, can you tell me what will be the end behavior?
Sir, it will go to minus infinity.
Yeah. So again, like for the last question, actually, we have used the right side end behavior, right? So we have started our graph from this side. Okay, so as I already said, there is nothing special about this side. We can also start from this side. Okay, let me for this question, let me start with the left side. So for the left side, what we need to find? We need to find this end behavior as x tends to minus infinity. Okay, so can you tell me what will be the left side end behavior of this polynomial? So as x tends to minus infinity, where this polynomial will go?
Towards infinity.
Q of x tends to infinity.
Yes. So as correct. So as x tends to minus infinity, this 2 times x power 11 will go towards plus infinity.
Yes.
Right? So as I have already said, this end behavior is completely depend on the end behavior of this polynomial is completely depend on the end behavior of this leading term. So that means this q of x will also go towards plus infinity. Okay. So our last thing is basically to find out the roots and its multiplicity. Okay. So the roots are one is
Minus 7.
minus 1, minus 3,
-4, -7.
Minus 4, minus 7.
and the next is
2, 5, 6.
5,
5,
6.
6.
Yeah, once we have all these roots, then we need to find the multiplicity.
Multiplicity.
Multiplicity of -1 is 2. This is 1. This is also 1. Minus 7 is 2. This is
2 is 1.
1. 2.
And again 2.
2, right? So now more or less we are ready to draw the graph of this polynomial. So we have this is -1, this is -3, this is -4. Okay, I have one more thing.
-7.
-7. And this is 2, 5, 6. So as we have computed basically the end behavior of this polynomial in this side. Okay, on this side actually we have computed. So let me for this polynomial let me start with the left hand side. Okay, so first thing is first I need to reach to this point -7, 0. So from which direction I should come to this point?
Upward.
Upward direction, sir.
Upward direction. See, so the thing is, as you can see, this q of x is going towards plus infinity. See, if this qx is positive, it's going towards plus infinity, then you should come from this side, right? If you are coming from the below side, that means your q of x is negative. Okay, so this side means q of the polynomial q of x is negative. Okay, so and this side, which is above x-axis, your q of x is greater than 0, greater than 0. So this above side is positive. So as you can see, your q of x is precisely going towards plus infinity, right? So you should come from the above of your x-axis. Okay, so it will come like this, then it will reach this point -7, right? And then
Yes.
next what will happen? It will
bounce back.
Bounce back.
It will bounce back. Then again, it will come to this point -4, -0.
It will cross.
Cross.
Yeah, because the multiplicity of -4 is 1, right?
Yeah.
And again, it will go to 3 and it will cut because same reason. And then it will come to this -1, -0 and it will bounce back. Then it will go to 0 and it will cut this point 2. Again, it will go to 5, bounce back, and again it will go to 6 and bounce back, right?
Okay, sir.
So as I said, you just need to know the end behavior of one side. Once you know the end behavior of one side, then if you draw the graph correctly, then you can also understand the end behavior on the other side. Okay. So this is basically, this is the rough diagram of this polynomial. So now can you tell me what is the number of turning points?
10.
10, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10 done. So any doubt from this part?
Yes, sir. One doubt, sir. Sir, hello.
Yeah, you're
The end behavior, sir. Yes, I want to ask one thing, sir. So if the leading coefficient is, we have to find the end behavior of left side, and if the leading coefficient is positive, like if it is x to the power 11, then it will go to minus infinity. If it is x square, then it will go to plus infinity.
Yes, correct. If the leading coefficient is x square, then certainly on the left hand side. That means
on the left hand side.
If x is basically going towards minus infinity, then x square is certainly, it will go towards plus infinity. Yeah.
Okay, sir. On right side, if it is x to the power 11, and then it will obviously, in both cases it will go to infinity on right side.
No, for x square 11 you are saying.
No, sir.
For x square 11 and for x for x power 11 and for x square, in both the cases it will go to plus infinity on the right hand side. Yeah, you are correct.
Yes, sir. I understood that end behavior, sir. I understand.
So again, like it's depend on the power. Okay, so the end behavior actually depends on two things. One is this power, okay, as well as its coefficient. Okay.
Yes, sir.
Yeah. Okay, anything else?
No, sir.
So one question, sir.
So one more thing. Does end behavior, which means if it is plus x power 11 or minus x power 11, when x tends to minus infinity, y will tend to difference, sir. Will same only, no, sir?
No, it's no. So the thing is, see if you take this x power 11, right? And one thing is minus x power 11. That is what you are asking, right?
Yes, sir. Yes, sir.
So the thing is, in both the cases, see, so here, if x tends to plus infinity, then what will happen to this x power 11?
It will go to plus infinity.
It will go to plus infinity, right?
Yes, sir.
If x, so for the second case, please mute. Okay, I don't know from whom actually I'm getting them. This plus infinity, where this, okay, let him answer this question. So what will happen here?
So 11
Okay, so
plus, it will go to minus infinity.
yeah.
No, correct. Correct, sir.
Sir,
Yeah. Okay, sir. If it was
Sir.
x square, then it will go to minus into minus 2 times. It will go to plus infinity. Okay, okay. The NBA depends on both
When
the minus.
see in x square, see if it is x square, then if you are taking this x square plus infinity, okay, then you don't have anything. You don't have to deal with minus, right?
Yeah.
So you said minus time minus. So there is no concept of minus here when you are taking only x square.
No, minus x square, sir. When it is minus x square, now when x tends to positive, still y will also tend to positive.
No, why?
No.
Why?
Negative.
Still it will go to negative, right? See, it has not. Okay, so the thing is, what actually you don't have to do anything. See, you take a positive number 1, right? You take 1. You take 1. What you will get?
1.
Come on. How? If you take 1, what you will get for here?
Minus 1.
Minus 1. You are getting negative, right? If you are taking a positive thing, you are getting negative, right? Then it should go to a minus x square. Will go to negative, right? Minus infinity. Right?
No, that was my first doubt, sir. If whether the power is odd or even, the n behavior only depends on
both the things, the power as well as the coefficient.
No, but minus x power 11 and minus x power 2 both are tending to negative only, no, sir.
Sorry?
Yeah, first last line and the last before line, minus x power 11 is tending to minus infinity. Minus x power 2 is also tending to minus infinity.
But this is not tending to minus infinity, right?
No, but again, x square also will not tend to minus infinity.
Yeah, that is what I am saying, right? This end behavior depends on this power, okay, as well as its coefficient, right?
So maybe, sir, if we can add, if it is an even degree polynomial, right, both ends will be either positive or negative. And if it is an odd degree polynomial, one side will be positive, one side will be negative.
Yeah, so it will have. Yeah. You don't have to actually remember anything here. Okay, it's more or less you don't have. See, as I said, you put,
minus 1. That's all.
You put 1, what you are getting minus 1, right? That means this basically means if x is going towards plus infinity, this thing will go towards minus infinity. You just simply substitute a positive number and a negative number, that will give you the answer. So if you substitute minus 1 here, okay, for this case, if you substitute minus 1, okay, if x is minus 1, what you are getting in this case?
Minus 1.
Minus 1, right? So that means for this case also, if x
Tends to minus
infinity, your x minus x square
also go to minus
will go to minus infinity. That's all. You don't have to like remember anything. So by just simply putting a positive and negative number, you can get the end.
Sir, excuse me, sir. Is it enough that we remember these two graphs of x square and x cube and minus x square and minus x cube, and then you will be able to
No. I don't think so. Like you have to understand the concept. Okay, so you don't have okay to basically the only thing that you need to remember is basically this thing. If the multiplicity is odd, then it will cross the x-axis. Okay. Yes. If the multiplicity is even, then it will bounce back. That is the only thing you need to remember. Apart from that, I don't think you have to remember anything. Apart from that, you have to
behavior. It is just you substitute minus 1 and check, is it?
Yeah, you just substitute. See, the thing is what we are checking. We're checking where this thing will go when you are going in this direction, right? That is what you are doing. So again, just you substitute some value. So instead of you substitute any positive value. Okay, you substitute x equal to 1, or maybe x equal to 10, or makes x equal to 7, whatever is your favorite number, a positive number, you substitute there. That will give you the
Positive
end,
side.
yeah, end behavior on the positive side. Okay.
Okay.
And whatever is your favorite negative number, you substitute there, it will give you the end behavior on the negative
side. Okay.
Yeah,
Okay, sir. Thank you.
yeah. And again, so the thing is, you need to find this leading term correctly. Okay, once you find the leading term correctly, then only if you substitute some positive value, then you will get the correct answer. Okay, if certainly if you are getting some, so if your leading term is wrong, then it will definitely, most likely it will give you the wrong direction. Okay, any other doubt?
Sir, here we get, like, from the observation only, I'm asking the question that if we have a degree of polynomial 11, we get the turning point 10. If we get the degree of 9, we get a turning point 8. So is it something like relation that less than one turning point than the degree?
So there is the statement, actually, this I guess in the lecture professor has said it. So if you have a degree, for a degree n polynomial, you can have at most n minus 1 turning points.
Correct.
So for this case, actually we are getting precisely n minus 1 turning. Okay, so this is 10 turning points. So here we have maybe 8 turning points, right? Okay.
In one it is 8, and one it is 11.
So for example, if you take, let's say, this polynomial, let's say, so you take this polynomial p of x equal to x minus 2 power 9 times x plus 1, right? So what is the degree of this polynomial?
10.
10, right? 10. And as you can see, what is the leading term of this polynomial?
Plus 1.
Plus 1.
1.
Power 9, okay.
Leading term, actually, I'm saying. I'm not asking the coefficient of the highest power.
X ki power 10. X ki power 10.
Correct. X power 10. And the roots are basically 2 minus 1, right?
Roots are 2 and minus 1.
And
multiplicity 9
and 1.
And
1. So now you draw the graph. Okay. So if you draw the graph, this is,
we can expect only one turning point.
Yeah.
There is only one turning point, right? For this graph?
Yeah, probably. Yeah. Let me draw. So, so this will be something like this. Yeah.
Yeah, 2 there will be slightly.
Yeah, so this again, like, certainly.
So there's one clue I found. Please correct if I'm wrong. So if the roots have either 2 or 1 as the powers, it will have n minus 1 turning points. But if any of the roots have more than 1 or 2, like for example 3 or 4, then you will not have n minus 1 leading term. It will reduce. That's my understanding.
Yeah, most likely, I guess you are correct. So let me think. If you have only 2, then it will continue.
See, the 2 examples that we saw earlier, it all has either 1 or 2 as the power. So whenever the powers are 1 or 2,
yes,
you have n minus 1 turning point.
Because when
one is turn.
Yeah, you are correct.
Okay.
Yeah. So as you can see here, actually you have only one turn, right? So again, yeah. So again, it's depend on the polynomial. Like someone already said, like if you have degree 1 and 2. But okay, so my guess is your statement is correct. But again, one has to
Means it
think
is
of,
precisely better to go like that only. First find degree, then leading term, then roots, multiplicity, draw, and only decide, right?
yeah. It's always better to do in this way. First,
Go
you try
through
to,
procedure only, huh?
yeah, you try to draw the graph, then
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 only
you try.
decide.
Yes.
Okay. Okay. Thank you.
Yes.
I have a question. So, what is the degree of equation x cubed?
What is your guess?
It is like 2.
Degree of
x cubed, equation x cubed. So, because most of the axis lies on the x-axis, right?
What is the definition of degree?
I mean, sorry, my question is number of turning points.
X cube.
Yeah.
So x cube has 0 turning points.
Okay.
So again, like, see, the thing is, actually we are actually so ignoring few things. Okay, so basically, so in some sense, actually we are considering so we are not actually considering all the points at which the slope of the function is 0. Okay, we are not considering all the points. Okay, we are actually ignoring few points. Okay, see this. So in some sense, actually, we are not considering all the inflection points. Okay, sorry, not in inflection. We are not considering all the critical points. So we are actually ignoring few critical points.
Okay.
So for example, even if you take this x cube, so you have a graph like this, right? So at this point also, the slope of this polynomial is 0. Okay, but we are not considering that. Okay. So
okay.
this is a critical point. Okay, this is a critical point, but it is slightly different. Okay.
Yes, sir, we can proceed.
We can say it is a saddle point.
Sorry, can you repeat?
Can we say it is a saddle
Yeah,
point?
that is what you have studied, right, in week calculus part. It's a point of maxima or minima. So basically we're taking all the points which is either a point of maxima or it's a point of minima. Okay. So that's why actually we are considering only these points. Okay, this type of point. So this is a point of minima, right? So if you see, this is a point of local minima. Okay, this is a point of local maxima. This is a local minima, local maxima, local minima, local maxima, local minima, maxima, minima, maximum. Okay, we are actually considering all the points which are either a local maxima or minima. So this point is neither a local maxima or nor a local minima. Okay. So that's why actually we are not considering all these points.
Sir.
Okay.
Yes.
Sir, can you tell how the graph has come between 2 and -1 in the before problem?
Sorry?
In this problem, how the graph has come like this. We have found the leading term and we have found the roots and the multiplicity. So based on this, how we have drawn this graph?
So do you so can you tell me how we have drawn this graph?
Sorry, sir. I attended just now.
Yeah, you can check the recorded session.
Okay, sir.
Yeah.
Yes, sir, we can proceed, sir.
Yeah. So, okay, like this is the last question actually I wanted to solve. So I don't have much to do. Okay, so after that I can take your time.
So
are we covering week 5 and
1 to week 6?
Yeah.
Okay, sir.
In application, only one small question, sir, doubt is there, sir, in this. After we finish this, I'll ask, sir.
Yeah.
Yes, sir, I will also ask after all this session will complete.
Yeah. So that's why actually I didn't.
Sir, this revision PDF, will it be uploaded in the portal, sir?
I don't know, like if you think this is useful for you, then I can send it to the portal.
Because sir, actually, though we have gone through all this, I feel personally that everything looks new to me. It is
Okay,
like
okay,
that. So I
I'll
need
send.
a
I'll
brush up. So
yeah, we'll
also,
upload.
sir, this week 12, week 11 practice assignment solutions and graded assignment solutions are not uploaded on the portal.
No, someone, yeah, got your point. And someone also pointed out that some mock solution also are not.
Yeah.
So
Will
we'll do
it be uploaded, sir?
Yeah. I'll inform the team today. Yeah. So
Okay,
portal
sir,
team,
thank you.
they'll up.
Thank you.
Thank you, sir.
Okay, so you have this function, right? So this f of x equal to e power a times x square minus 7x plus 6, where a is a real number. Okay, so this is the function. So you have bunch of statement. You need to find which of the following options are correct. Okay, so the first option says f of x will be positive when x is precisely in this interval and a is greater than 0. Okay, so what is your opinion about this statement 1?
Yes, sir.
Yes, why?
Yes, sir, it is positive.
Sorry? So someone was saying something. Yeah, whatever you said, it's correct. Can you repeat?
Sir, it will be positive, I think.
No.
E power x will always
Because
The range of e power x
the
is
range
always
of e
greater
power
than
x is
0.
anyways
Yes.
positive.
So e power x is always greater than 0, right? For all x in R, right? So then it doesn't matter what is actually x and what is a. Okay, so it doesn't matter what is a, what is x. So this e power x is always so it doesn't matter what is coming. Okay. So it doesn't matter what is the range of what is the value of x, and as well as what is the value of a. So it's completely irrelevant. So in both the cases, this f of x is always positive, right? So that's why this option 1 is correct, as well as option 2 is also.
Yes, sir.
Yeah.
It is 1 as well.
Why?
Sir, one question.
Sir,
Sorry.
because it is an
If the
increasing
power is
function.
negative, still e power negative power is greater than 0, is your saying?
What is the that is what I am saying. Yeah.
It will come in rational number, and that's why.
It's
then
not
positive.
1.
Not
It's 1 divided by e. Okay, sir, got it.
It's not rational number.
Yeah,
E is itself is a irrational number. Okay, so.
No, I'm saying it will come in fraction. Then it will be positive.
Yeah, it's certainly I agree, but yeah, certainly it's not a rational number.
Yes, sir, of course.
I got your point. Yeah. Okay, so what about option 3?
No, sir, not 1.
Not 1, sir.
Not 1 because it have two roots, sir, in quadratic equation.
So what are the roots of this quadratic equation?
Minus 6, 1.
Minus 1.
Minus 6,
6
minus
and
1. Minus 6 and 1. Yeah. So basically, if you factorize this, then you have x minus 1 times x minus 6, right? So at x equal to 1, f of x is what? F of x, no, not 0, it's 1.
1, sir.
Okay, because what you will get e power 0, right? This is
1. Okay.
So x equal to 6 also it will give you 1. So this is not
1 to 1. It's not 1 to 1.
So this is incorrect. This statement is incorrect. What about the last option?
If a is equal to 1.
Incorrect.
So incorrect, sir. It doesn't have any x-intercepts.
So x-intercept means what? It will cross the x-axis, right?
Yeah.
That means the y value is 0, right? So it doesn't.
Yes,
so as I already said, this e power x is always greater than 0, right? So it doesn't matter
of course, sir.
what the value of x is. This e power x is always greater than 0. So that means it can't cross the x-axis. Okay. So it can't even forget about crossing. It can't. can't touch the x-axis. So this statement is also incorrect. Okay. So is there any doubt from question number 6?
No, sir, no doubt.
Okay. So
Just
now you can ask your doubts. I can take your doubts.
Sir, will you take from log and limits also today or later?
Yeah, next session. There is a session on 7th, right? So we'll discuss about.
So mock 8 question 10.
So this is only till week 4 or week 6?
It's
4, I think.
So again, like I'm not going to take any question
Request.
that are outside of week 6. Okay.
Sir. Sir, mock 8 question number 10.
Mock 8
clarification. Sandhya, new company they are launching, no sir? That question. It says one of the including the year in which company was lost, it neither made profit nor loss in 6 times. Okay, 0. So when my question is, when the company was launched,
so can you tell? So what from where you are asking the question?
Mock 8.
Okay.
Question 10. Okay, second time when I'm reading, I'm trying to get something.
Mock 8.
Yes, sir. Yes, sir. I got now. I think after reading again, I'm getting the answer. I think, sir. Okay. It says including the year in which company was launched. Actually, when it was x equal to 0, y it also will be 0, no, sir? In that question.
If x equal to 0, yeah, y is also 0 because
So
you have x square, right? You have x square. If you substitute 0, then basically you will get 0.
No, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 is the coefficient. I mean,
so the thing is, one thing you need to do is basically you need to draw the graph of this polynomial.
Yes, sir. I drew the graph, and then it says neither made profit nor loss. Means I thought differently, but now when I'm reading again, I'm getting there. In when the company started means x equal to 0. That time y equal to also 0. That means they are not made profit nor
loss.
But when you see on real life, when you start a company, how can you make loss or profit on that same year? I mean, same day. 0, 0 is that it's starting, no, sir?
Yeah. So okay. So again, like, so you should not, in some sense, you should not compare all this question to real life literally. Okay. So this is sort of toy example. So
I had the same doubt.
Okay, so for this type of our exams in this, when if x equal to 0 and y is also equal to 0, that time it is same. So when the polynomial has something like that, when x equal to 0, y is having some value, positive value or negative or whatever it is, then we can take it as positive, I mean profit or loss accordingly.
Yes, correct.
Okay, so we should not think whether when you start itself, how can you have profit or how can you have loss and all.
So again, like you just think all these things as a function. Okay, so according to that you decide. Okay, so if x equal to if x is if x equal to 0 and y equal to 0, then basically you have neither profit nor loss. So you try to take it as some mathematical model. So.
Okay, that is done, sir. Then this okay, this one we are not taking question. Raymond's graph next time I'll ask.
Yeah.
Sir, okay, this also is continuity. Okay, sir.
Yeah.
I want to see notes.
Sir.
Yes.
Sir, can you teach log very briefly, sir? I have so much doubt in log.
Yeah, what is your doubt in log?
Sir, many questions. Let me ask, sir. Wait a second. So like in activity question 6.4, question number 2. No, question number 1, sorry. Question number 1.
6.2.
6.4. Logarithmic function and properties 1. 6.4 assignment. Like activity assignment. Question number 1. So can you explain this question?
There is nothing to explain here. This is precisely the property of log, right? So what is the property of log? What is log m square? This you can write is a 2 log m, right?
Yes, sir.
So that is what this question is.
No, sir, it is asking.
This is what it's asking.
Oh, okay, sir. Sir, okay, sir.
You have log a m square, right?
Yes,
so
sir.
you
Sir,
have
actually,
log
sir,
m base a, okay, and then this is precisely this 2 log m base a.
No, sir, actually, okay, sir. This question is also easy, sir, but I have some doubt in log, sir. Actually,
no, that is what I am saying, right? You have to tell your doubt. What is the doubt? Otherwise, how I can answer your question? See, you now you certainly can't say that whole week is my doubt. Okay, so
actually, I want to ask, sir, how to find a domain, sir, of if we just if
yeah,
the
that
log
is what I will suggest. See, the thing is, I will suggest to ask the session on log. Actually, as far as I remember, specifically in a session, actually, I have explained all the questions from 6.1 and 6.2, which is completely that session is completely dedicated to find the domain of log function.
Sir, when, sir, sir, I think I don't attended that session, sir. When?
Yeah, so you can go and check the recorded session. Okay, you go to your calendar. Okay, so there you can get the YouTube links. Okay,
open session for week 6.
I don't remember which one, but I remember one of in one of the week 6 session I have discussed all the specifically how to find the domain of
sir,
logarithm.
I will see, sir. Okay,
Yeah.
thank you, sir. I will see.
Sir, question number 9 in the mock 8.
Question number 9.
Week 1 to 11 mock 8.
No, again, like as I said, I will take only questions from week 1 to.
It is that only, sir. Coordinate.
Yeah, then no problem. Question number 8, right?
9.
Sorry, 9. Yeah. Yeah, what is the problem here?
Sir, how to find the D?
Yeah, this question, I guess, we have asked you in some of your quiz, right?
Quiz even I don't know. It means I don't remember. Sorry, sir.
I guess we have asked you this probably, I don't know, probably in quiz 1 or maybe in qualifier exam.
Similar kind, sir, in qualifier.
Yeah, so it's more or less the same question. Like it's slightly different. I guess it's the curve is slightly different there, and here it's both the parabolas are opening upward. So here I guess it's opening downward.
Opening downward, huh?
Okay, so so let me draw the graph itself. So 1 d comma 0 13 comma 0, right? So can you tell me what will be the equation of this p of x, and let's say this is this is 1 comma 0. This is d comma 0, right? This is 13 comma 0.
D comma 0, 13 comma 0. The leading term is positive.
This is
That
P.
is given.
This is Q.
This
right?
is Q.
So what is the, okay, so let me read the question again. So consider two quadratic polynomials P of and Qx whose roots are given and the leading coefficient is
Px
1.
and Qx is 1.
The y
coordinate vertex point Px and Qx are same.
Yeah, so y coordinate of P of x is equals to the y coordinate of the Q of x. Okay, so that
I do from
so that basically says this point
x is equal. These points are same.
Y coordinate of these points are same. Okay, that means if you draw this line, then actually it should pass through these 2 points. So okay, so first tell me what is the equation of P of x?
P of x. Px square bx plus c.
So x minus 1 into x minus b.
Right, sir?
This is x minus 1 times x minus
d.
Right, because it is given, right? The leading coefficient
The leading coefficient
is 1, right? Then what will be the equation of Q of x?
Then x minus d and x minus 13.
X minus 13 times x minus d, right?
Right. Leading coefficient is 1.
Yeah. So what is the y coordinate of the vertex for P of x? What is the y coordinate of the vertex of P of x? So what is P of x? If you multiply P of
x square minus bx minus x plus d x square minus plus 1 plus d. Px is equal to x square minus 1 plus d x plus d.
So what is the y coordinate of the, so what is the y coordinate of the vertex?
Okay. X is equal to by 2.
P 1 plus d by 2.
So this is the x coordinate of the vertex, right?
This is 1 plus d by 2. At this point, Px we have to find out.
So to get the y coordinate, you need to find 1 plus d plus 1 by 2, right?
2, correct.
So if you do it, then what you will get, this is precisely d plus 1 by 2 minus 1
plus d.
D plus 1 by 2 minus d, right?
Right.
So this is the y coordinate of P of x, right? P of x, right? So this is your y coordinate of P of x. Then similarly, what will the y coordinate of Q of x?
That also we have to find out.
You need to find, right? So,
right.
So again, you find the y coordinate of Q of something.
And then we equate.
Then you equate. From there, you can get the value of.
Okay, correct.
Yeah. So you will get some
quadratic equation, and I think we have to get it.
Yeah.
And if there are two values, then if it is positive, that only we have to take something like that, I think.
So here, certainly from the graph, it's
we have to guess it that it will be between 1 to 13.
So yeah, so see, yeah, D is basically it's positive, right? So,
positive, right?
Yeah.
Okay. Then I'll solve, sir. Thank you.
Yeah. Okay. Anything else?
So can you give a small revision of composite function? How to find
Hello, sir.
Yeah.
So can you teach how to find domain in composite function?
Okay. Okay, so So first tell me, so okay, so before knowing going into this composite function, first tell me how we can get the composition of two functions. So let's say you have a function f of x equal to, let's say, x square plus 1 plus 2x, and one more function g of x is, let's say, e power let's say x. So can you tell me what is f compose g?
It means f of gx.
F compose g of x. Yeah, correct. This is precisely f of g
F
of
of
x. G. Yeah. So what is that? What is that function f of g of x? No, I'm not. No. Whoever asked, sorry, whoever asked that question, I'm asking to them. Okay. So don't answer the question.
So can you repeat the question?
Question is, what is f of f compose g of x?
So f of e to the power x.
Yeah, what is that f of e to the power x? That is what I'm asking.
So e to the power 2x plus 1 plus 2 into e to the power x.
Correct. E power 2x plus 2ex plus 1. Okay, so this is the composite function. Okay, so what is the domain of f? What is the domain of f? What is the domain?
Real number.
Correct. So f is basically, it's a function from R to R. Okay, and similarly, what? Okay, please, I am getting some echo. Please, whoever it is, mute yours. G is also a function from R to R, right?
Yeah.
So that means this composite function, okay, is also a function from R to R. Okay. So the difficulties comes when you have function which is basically not from R to R. It's a subset of R, right? That is the main, I guess that is the main reason. That's why you have asked. Okay. So okay, let me take some slightly complicated function. So you take f of x, which is 1 by x minus 1, right? And you take g of x, which is
So can we take in g of x tan of x or something like that?
g of x is, you want to take tan of x.
Yes, sir.
You can take, but again, tan of x is slightly
And sir, when it is just the one you explained about, that one is easy. But still,
So let me take
in
this.
In the second equation, if you are having tan of x and also the mod for that. So
That
how?
Okay, so again, I don't think that will change much. Okay, so let me take tan of x. So I'll come to that. So basically, the thing is tan of x and mod of tan of x. So when tan of x is -1, actually, so you just need to. So first tell me what is the domain of this tan of x?
Like only it is not defined only at the pi by 2 and like minus pi by 2. At that point, they are not tan.
Okay, so it's not clear. Like, okay, so I don't know. See, some noise. Okay, so yeah, so this tan of x is basically, it's not defined. So okay, so this is precisely what? Sin x by cos x, right?
Yes.
So this is not defined at all these points where this cos x is 0, right?
Yes.
So where this cos x is 0?
At pi by 2 and
Sorry?
All values n into pi by 2, like all
Try down. With that out.
N into?
pi by 2.
N into pi by 2. So where this n varies?
On like natural number is it can get taken.
So if I take n to be 0, then what will happen? Sorry?
At all values of n pi.
All the odd numbers, yeah, correct.
For all odds.
Yeah. Okay, so now you take this composite function. Okay, so this is what? This is 1 by tan x minus 1, right?
Yes. Yes.
Yeah. So in this composite function, okay, so to find the domain of this function, okay, first thing is what you need to do. You need to remove all the points, okay, which are not in the domain of g of x, okay, and as well as which are not in the domain of f of x, right? So what are the points which are not in the domain of g of x? These are the points which are not in the domain of x, right?
Yes.
So first I need to remove all the points which are not in the domain of g of x. So what I need to do, I need to subtract all the points which are not in the domain of n times pi by 2, where n is odd, right? I need to remove all these points which are not in the domain of g of x. Next, what I need to do, I need to remove all the points which are not in the domain of f of x, right? So which point is not in the domain of f of x?
Positive 1.
Positive 1. Okay, so again, so this set, whatever I am subtracting, this is again I have to include 1, because 1 is certainly not in this first set. Okay, so I have to separately I have to include.
But actually this tan of x, the range we should minus.
Sorry? No, I'm computing the domain of the function. Okay, I'm computing the domain of the function. Okay, so I'm to compute the domain, as I said, first you need to subtract all the points which are not inside the domain of g of x. So these are the precisely all the points which are not in the domain of g of x, right? And second thing, what you need to do, you need to remove all the points which are not in the domain of f of x, right? Yeah. That is 1. Only 1 is not in the domain of g. And next thing, what you need to do, see, for some values of x, right? For some values of x, g of x can be 1, right? Some values of x, g of x can be 1. Correct or no?
Yes, sir.
So, but if g of x is 1, then what I will get? I will get f of 1, right?
Yes, sir.
But f of 1 is not defined, right?
Yes, sir.
So I need to remove all the points in the domain of g, such that g of x is 1, right? I need to remove all the points. I need to remove all the points. Remove all the x x such that g of x is 1, because see, if g of x is 1, then what I will get? I will get f of 1, and f of 1 is not defined. Okay, so also I need to remove all this x. So basically what you need to find all the points, all the x, such that tan of x is 1, right?
2n plus 1 times pi by 4.
Probably, yeah. So 2n plus 1, probably this is correct. You need to check it properly, but certainly at pi by 4 it is 1. Okay, but you need to check the graph properly, and you need to find what are the basically all the points at which this tan of x is 1, and you need to remove all these points. Okay, so you need to remove 2n plus 1 by 5n. So this R minus this set, okay, R minus this set is precisely the domain of this composite function. Okay. Is it clear, this particular question?
But sir, like we have included this one.
Sorry?
One, sir. But if it is a composite function, but if tan will take 1, then that function is defined. It is not defined when the range of tan of x is 1. Isn't it, sir? So 1 can be in the domain,
Yeah,
but
so
1 cannot
again,
be
like,
in the range.
so you again, like, see, the thing is, it's depend on how the lecture professor is defining this. So if you see the lectures of Nilesh sir, then basically he has defined all these things. So he is also excluding all the points which are not in the domain of f. Okay. So that's why actually I have excluded this one. Okay, but in many
but in many cases we include
yeah, that is what
one and also that.
Yeah, that is what I'm saying, that so in many cases actually they don't exclude this one. So basically what they takes all the points which are not in the domain of g of x and all the x such that g of x is 1, right? So they generally they don't consider all the points for which f of x is not defined. Okay, but that is what so Nilesh sir is doing slightly different too. He is also excluding all the points which are not in the domain of.
But
So it's,
but in the term, like, but in term which pattern we should follow? We should
this pattern. Yeah, this pattern. Yeah, whatever whatever professor said, you have to go do it according. Okay. You need to consider these 3 cases, and you have to remove all the points which are coming under these 3 cases.
So we have to remove the 1 as well from this.
Yes, correct.
Thank you, sir.
So one doubt in polynomial function.
What is your doubt?
How you know that the graph of the polynomial function will start from above the x-axis or from the downward of the x-axis?
That I have discussed thoroughly in this session. You can see the recorded session. Anything else?
Sir, I have a question. I mean, regarding polynomial. So, sir, if let's say if we have a degree 4 polynomial, it is like x plus 2 into x minus 2 into x square plus 1.
Just a minute. X plus 2.
X into x minus 2.
Into x minus 2.
Into x square plus 1.
X square plus 1. Yes.
Yes, sir. So, sir, what kind of graph behavior we should like consider for this kind of graph? I mean, like how to approach this and all that.
So again, like as I said, so if you don't know all the roots of the polynomial, right? If you have some complex root, okay, then certainly you can't say much about the graph of the polynomial. So if you see whatever polynomials we have taken, Okay, we know all the roots of the polynomial, right?
Yeah.
So here the problem is you have two complex roots, right?
Yes, sir.
You have two complex roots. Okay, so
Complex
for
roots, yeah.
when you have complex root, actually you have to draw the graph maybe slightly careful. Okay, and again, I don't think you can draw it for all the cases. So one thing actually you can say. So one thing you can say that certainly it has two roots, right?
Yes, sir. Like -2 and 2.
Okay, so yeah, so it will come like this. Okay.
And it will cut the x-axis and go below.
Yeah, so and if you take x towards -infinity, then what will happen? Again, it will.
So it will go upward again. Yeah, like that.
Yeah. So the thing is, most likely it will. You don't have any choice. Most likely it will go in this way. Okay, certainly it's not going to cut your x-axis anywhere else because you don't have any other real roots, right?
Yes, sir. Yes, sir.
Yeah. So, but again, like in generally, I don't know. I am not sure whether you can draw the graph for any arbitrary polynomials. Okay. So maybe for some specific case, you can draw the graphs. Okay, but when you have complex root, then basically it's you can't apply that method.
Okay.
Just let me
But
check.
sir, like in this, the degree would be 4, and we can say that at most it can have 3 turning points. Can we say that, sir?
Actually, this can happen actually. So the problem is actually, see, if you see whatever I have drawn here, okay, so I have predicted some. I don't know actually what is happening in here. Okay, that is the biggest problem. Okay, that I don't know. Okay, so basically I made a vague case. Okay, maybe it will be like this. Okay, but maybe it can be something like this. It can be something like this also. Okay, or maybe it can yeah, so it can be something like this, right? So
I mean, sir, for this given, for this given example, sir, if we want to find the y-intercept, it's pretty easy, right? I mean, putting the, x equals to 0, so we can find y equals to -4, so we can at least have the y-intercept. So for
yes,
this
but
given
again,
example, we can have that.
But again,
not for everything.
But again, if you get the y-intercept, then certainly it's not going to give you much information, right? How this polynomial is behaving. So see, if you know the y-intercept, so suppose your y-intercept is, let's say, minus some. So this is your y-intercept. Okay, let's say this point is your y-intercept, right? So then your polynomial can be like this, right? Your polynomial can be like this, right? Your polynomial, and also your polynomial can be like this, as I have said.
Yeah, exactly.
And also its polynomial can be like this. Okay. So certainly this is not possible. So most likely either either it will be like somewhat like this, or it will be like this. Okay. So it's depend, like, so if you have complex root, then it's difficult to say.
Okay, so got it. So that is the unusual behavior that we don't know so far. I mean, according to this, like
yeah. So graphing actually, you can apply the rule actually when all the roots are real. Okay. So you can't apply for complex roots.
Okay, sir. Got it.
Yes.
Sir, I have a doubt, sir. Hello. Sir, before that you explained n minus 1 turning point. Sir, can you explain it briefly, sir? I don't understand why n minus 1 turning points. Okay.
Where?
Where you explained n minus 1 turning points in a polynomial.
So here the degree is 11, right?
Yes, sir.
So from I have actually drew this
10 turning points. Yes, sir.
This graph, right? So this is the graph of the polynomial, right? So this is a turning points, right?
Yes, sir.
This is a turning point.
10 turning points are there. Yes, sir.
Yeah. So then, yeah. So clear, right? These are 10 turning points, right?
Okay. Achha, n is the power. Oh, sorry. Yes, sir.
N is the power. So again, this is not true in general for this polynomial. This is a degree 11 polynomial. For this particular polynomial, you have 10 turning points. Okay. You can have a degree 11 polynomials. Okay. And the number of turning points is 0. Okay. If you take this polynomial, P of x is equal to 11. Okay.
There is no turning point, sir. Okay,
P of x is equal to 11.
Then x to the power 11.
It has
no
turning
points.
No turning.
Yes, sir.
Okay, so it's something like this. Okay,
in short, we have to first fully solve the question. Then we will decide.
You need to draw the graph of the polynomial. Okay.
Yes,
once you know the graph, then from there itself you can say something about the number of turning points.
Okay, sir. It means that it is not permanent, sir. N minus 1 has.
No. So see, the n minus 1 is basically the maximum possible number of turning points. Okay.
Oh.
If you have a graph of degree n, okay, it can have maximum n minus 1 turning points. Okay. For example, if someone is saying this, if someone is saying that this is a degree 11 polynomial, right? If someone is saying that this has 11 turning points, then blindly you can say that your statement is incorrect. Okay, because a degree 11 polynomial can have at most 10 turning points. Okay, it can't have 11 turning points. Okay, but it's saying that the number of turning points of this polynomial is less than or equal to 10. Okay, but it's not giving you the precise answer. Okay, it can be 7, it can be 6, it can be 5, saying it's less than or equal to 10. Okay, that is what it's saying.
Okay, sir. Sir, so in a question, if it is given that find the maximum number of turning points of this, तो हम ये कह सकते हैं कि 10 है n minus 1 अगर पूछा है किसी ने कि maximum number क्या हो, कितने maximum हो सकते हैं turning point. Okay, sir. Thank you, sir.
Yeah, Naren.
Sir, one small clarification. Restricted domain, it is well defined in restricted domain.
So you are saying, so restricted domain is basically what you can actually restrict your domain. Okay, so for example, if you have a function, so this is a function from R to R, let's say x goes to x square, right? So I'm taking this function as a map from R to R, right? But I can restrict my domain. So I can consider this function from -1 interval to R, right? Now I'm considering this function from this interval to -1, 1 to R. So now this is my domain. Okay, so I'm basically what I'm taking a subset of, and I'm considering this function from this particular subset to R. Yeah.
Yes, sir. So apart from restricted domain, also the function is well defined only. But if in the given question from -1 to 1, it is defined. Whether it's true or false means it is true.
Yeah. See, if you are taking, if a function is defined on R, right, then certainly it's defined on a subset of R, right?
Yes, sir.
So then here it's correct, right? So you are restricting the domain. Okay, so basically you are taking a subset of the maximum possible domain. Okay.
Yeah. So this question is in relation to that mock 8 to 1 question, no, sir? That one.
Yeah. Just let me check.
That log question number 3.
Question number 3, right? Just let me check.
Question number 3, because it is not, it is defined even between 2 and 3 also. 1 and 2 also, but it is not given in that question. So answer is true.
Okay, so
now I understood, sir. Now, as you, after you told, restricted domain and full domain are different. If it is defined in restricted domain, and the question is whether it is the R x square, the function f is defined in -1 to 1. It is true. The
yes,
function x square is well defined in the restricted domain of -1 and 1. Answer is
yeah,
true. Even
yes.
though it is defined in other range also, other domain also, we need not worry about that.
Yes, correct.
That was my clarification.
See,
Thank
if,
you very much, sir.
so the thing is, if a function is defined on a big set, okay, so basically it's saying if a function is defined on a big set, it is also defined on a subset of that big set. That is what it's saying.
Correct, sir. Correct, sir. Yes, sir. Thanks, sir.
Yeah.
Sir, one more session we are having, sir, for week 7 onwards.
Yeah, you have 2 sessions. Okay, you have 2 sessions. So one session, sorry, you have 3 sessions. One session is today. Okay, it's basically from week 1 to 6. Okay, one more session is only for calculus. Okay, and the last session is for graph theory.
Okay, so I'll ask the Dreeman's problem in the calculus.
Yeah, we'll discuss all the question in the calculus session.
Thank you, sir. Thank you, sir.
Yes.
Sir, okay, sir. Sir, can sir briefly tell, sir, मतलब कि कहाँ सर हम लोग प्रैक्टिस तो ऑफ कोर्स पूरी करेंगे, मगर सर थोड़ा बता सकते हैं कि कहाँ से क्वेश्चंस आएंगे सर, मतलब कि आएंगे, मतलब कि मैं ये नहीं बोल रहा हूँ सर पर्टिकुलरली वहीं से आएंगे, मतलब कौन से क्वेश्चन सॉल्व प्रैक्टिस करके हमारा
we have sent you so one thing is we have sent you the weightage, right, week wise, not week wise, but in some sense this week 1 to 6 there is some weightage, week 7 to 9 there is some weightage, and week 9 to 11 week 10 and 11 has some weightage, right?
Sir, I have not got, sir. Where
mail we have got.
Yeah, we have sent you a mail. You go and check. Okay, and accordingly you decide what you
Sir,
want.
we have taken all the 4 subjects. So morning and afternoon we'll have exams, right? For the end term. It is
you have 4 subjects, right?
Yeah.
Yeah, then probably you have.
So morning 9 to 12 is one. It'll be 2 exams, and then post lunch 2 to 5 will be 2 exams.
I guess so. Yeah.
So कौन सा order में आएगा sir? First morning session में maths आएगा या afternoon session में?
That I don't know. You have to check the admit card. Okay, so once you get the admit card, then actually you will get all the information.
Okay, sir. Thank you.
Yeah.
Sir, can you explain a question in quiz 2?
Quiz 2 we have provided. We gave you the solution, right?
Yes, sir. But I have a doubt.
Which question?
Question number 97.
No, I don't have. No, you tell me the question. I don't know what is question number 97.
Consider a sequence 1, 2, 3, 4, 5, 6, and so on. That is, n is equals to n for all n belongs to natural numbers. Which of the following sequence are the subsequences of set an? It was given.
Yeah.
So in the ID, it was given the options as 1, 3, 1, 3, and so on. That is, bn is equals to 1 if n is odd, and bn is equals to 3 if n is even. I don't know why this option was wrong, sir.
So
it was given that n is odd. So for here, natural number starts from.
Just a minute. This whatever you say, this option is certainly wrong. Okay. Let me open the question. So this is your sequence. So your sequence AN. This is your original sequence, right? 1, 2, 3, 4, 5, 6. Okay. And so on, right? And you are taking a subsequence. What is Bn? Bn is what?
Bn is equals to 1 for n is equals to odd. N is odd.
1, 5,
Yeah.
1, 5, right? Like this.
Yes, sir.
So,
no, sir, 1, 3, 1, 3.
Okay, it doesn't matter. 1, 3, 1, 3. So here, if you see first, 3 is appearing after 1, right?
Yes, sir.
So in this sequence, as you can see, 3 is appearing after 1, right? Then, and in the next step, you see 1 is appearing after 3. Okay. So is there any 1 in this sequence after 3 in the original sequence? In the original sequence, is there any 1 after 3? But in the subsequence, you have a 1 after 3, right?
Yes.
Then certainly Bn can't be a subsequence of A, right?
Yes.
Okay, is there any other doubt?
Excuse me, sir.
Yes.
I have doubt in previous question paper. I was unable to solve that problem. Can you give some idea how to solve it?
What is that question?
This question is big somewhat. Let the curve CF represented by a polynomial f of x of degree 3 passes through the point minus 5, 0 and 2, 0. Curve CF intersects curves represented by the polynomials g of x equal to p into x minus 3.
Can you share your question?
Okay, sir.
Sir. Hello, sir.
Yes.
No, I have disconnected in between. So can you explain this? Continue.
You can check the recorded thing.
Sir, I was unable to share that question.
Sorry?
I was unable. Share screen is not on.
Just a minute. I don't know. No, so we don't share the question, then it will be difficult for me to.
Sir, I think I remember the question actually. I solved it actually. I think I remember the question. I mean, I cannot give you the values, but I can give you the overview actually.
Yeah,
about the question.
yeah, please.
Yes.
So, sir, there is a curve which is passing through 2 points.
Just a minute. So you have a curve which passes through
which is passing through, let's say 5, 0 and 3, 0. These 2 points. And that same curve is intersecting with other 2 polynomials, and the polynomial equation was given.
Minus 5,
and with x-axis as well, I guess. Yeah, as well as with x-axis. So that is given, and it is asked, and there was another polynomial. It was intersecting the main curve, the curve that is this one. This curve is intersecting with another polynomial.
Okay, sorry.
With some other points as well. So that was kind of like a lengthy question. That's why.
Yeah, so I need to read the question. Otherwise, it's difficult for me to solve.
But sir, I mean, sir, I mean, I have solved, so I can.
Yeah, then you feel yeah, you can give or some idea. Yeah.
Yeah. Okay. So see, if the points are given, like passing through 2 points, so it was given like 5, 0 and 3, 0, something with 0, right? So those are the x-intercepts. So that means you have 2 roots for that polynomial. And if you see the other 2 curves, there was a common point. I guess it was like x minus 3, x minus 5, something, right? So if you see both so 5 is the common point. So you can get the curves equation from the 3 roots actually. So once you get the 3 roots, so you can just equate that with the other 2 points. So if that curve is intersecting at those 2 points, so that means those 2 points would satisfy that curve, right? So for corresponding x value, you can just put the y value and calculate the value accordingly. And then I think it was given like a value, I mean, the y coordinate you need to find, right?
Yes.
For
Yes.
another point. So yeah, you can just satisfy for the one equation, I mean, sorry, for 1 point. So you get the value of a, because whenever plus bx plus c, so a into root equation, right? So once you satisfy 1 point, you can get the value of a, and once you get the value of a, and then you can just put the other value. Let's say it's 2 comma a, so a is like y value is a, so you put y equals to a, and then the x value put there, and you get the point. So then you could just equate that.
My first doubt is the first line. It is given the curve CF of degree 3, but they have given only the 2 points. I know
Yes,
2 roots.
yes. So you have 2 roots, right?
How to find the third root?
So see, you have other 2 polynomial equation, right?
Yes.
And it, yeah, and it is given that with those 2 polynomial equation, this curve is actually intersecting with the x-axis as well, right? So if you see those 2 polynomial equations, you're gonna see a common root in between 2 polynomials if you see closely. So that would be the another root for this given curve.
Okay, without drawing the graph, we can solve this. But
Yeah, absolutely, yeah.
I tried to draw the graph because without knowing the leading coefficient, we can't draw the graph. P and Q.
Yeah, but see, that is the thing I told you, right? Like you need to roughly draw like a into that root equation, and then you need to satisfy 1 point to find that leading coefficient. And then once you draw the curve, then you can just solve it.
Okay, I'll try. Thank you.
Anytime. So that was the question. It was like
okay.
6 or 7 line
I
question.
don't. Yeah, I somehow I can remember this. Okay, I guess I have discussed this question previously, but again I don't have that question. This, as far as I remember, this is a lengthy question, but the answer is it's easy.
Yes,
you don't have to do much. Okay, when you said that you know the 2 roots of the equation, so from there itself actually, yes, I guess someone already asked, like long back, someone asked this question in one of the sessions. Okay, so is there any other thing?
Sir, logarithmic functions graph.
Okay, you can again, like we have discussed all these things in details in logarithmic weeks. Okay, so you can go and check week 6 sessions. Okay, we have discussed all these things completely. Okay. Okay, so then I'll stop the session. Okay.
Right.
Sir, so I have a question.
Yeah.
So what is horizontally and vertically asymptote?
So horizontal, what is horizontal? Horizontal is basically something like this, right?
So parallel to y-axis, x-axis.
So when you have a asymptote like this, right? So when you have a asymptote to this x-axis, this is a horizontal asymptote, right? And when you have a asymptote like this, which is asymptote to y-axis, this is a vertical asymptote. Right? So you can have some graph like this as well, right? You have some. So this is a vertical asymptote, and this is a horizontal. So it's depend, like it's just a terminology.
So if any equation is given, then how to find the horizontal and vertical asymptotes of this equation?
No, it's depend on the question, like how there is no universal method to find this horizontal and vertical asymptote. Okay, so one thing is basically you need to find the in some sense so one way actually to find this type of asymptote. Okay, to find this type of asymptote, actually you can find the behavior of the function as x tends to plus infinity, right? And if you want to find this the horizontal asymptote towards this negative direction of this x-axis, that means towards this infinity, then you can find the behavior of the function as x goes to minus infinity. Okay, but there is certainly no universal method to find the vertical asymptote. So more or less you need to find the points where this function is not well defined. Okay, and once you find all the points where the function is not well defined, then you should check the behavior of the function at the neighborhood of that point. Then probably you can say something about the vertical asymptote. So there is no some specific trick to do all this. Okay. So for example, for some you can have some function which is not defined at a point, and also the function doesn't have any vertical asymptote. And for some function, this function is not defined at that point. Still, the function can have a vertical asymptote at that point. So this is not true in general. You have to check it carefully.
Okay, sir.
Okay, anything else?
So doubts is a bit clear.
Yeah, it's in the evening.
Sir?
The session is in the evening.
Sir, but I'm not able to join in. It's showing someone you will enter when someone let you in, but no one enter me, sir.
Okay, I don't know. We got some mail today. I will join that session as well. Okay, don't worry. We'll see you. What is the problem? Okay.
Okay, sir, I have a question. I mean, like I found it in the previous year question. I mean, there weren't that much difference in two equations. All I can say, like I cannot tell you the exact equation. I mean, the exact function, but there was the quadratic function within the log, and we had to identify the graph for that. And so
no, I don't think so. We have asked you about the graph of this function.
I mean, sir, in the previous year question, I found one
okay,
question.
Okay. Yeah. Got it. Yeah. Correct.
Yeah. So, sir, the thing is, like, I mean, for this, we need to equate this star thing to greater than 0, right? To find the vertical asymptote, since it's quadratic. So, sir, let's. I mean,
son, that is not enough. Okay, so that is actually not enough.
Yes, sir. That is my question. Like, what more we have to do after that?
So the thing is, see, so you want to draw the graph of this function, right? So
yes,
so the first thing is you need to draw the graph of this function. Okay, x square. So suppose you have a graph. Okay, so so suppose you have some quadratic polynomial. Let's say I mean, say p of x is what? X minus 1 times x minus 2, right?
Okay.
This is your polynomial. So if I draw this polynomial, this is my 1, this is my 2, right?
Yeah.
And my graph will somehow look like this, right?
Yeah, absolutely.
So if you consider this polynomial, let's say log of p of, if you consider this function log of p of x, right?
Yeah.
So first thing is this function is not defined on R, right? Certainly this is not defined in this region, right?
Yes, sir. Yes, sir. I mean the below part. Yeah.
This, yes, because so in this part the value of the function is negative, right? So this is not defined.
Sir. Yes, sir.
So then the domain of this function is basically
minus infinity to 1,
minus infinity to 1,
union,
and
then
2 to
2
infinity.
to infinity.
2 to infinity, right? And
closed.
Yes. So
No.
not closed,
Yes,
it's
sir.
open. Okay, so
open interval actually.
Because log 0 is not defined, right? Log
yes, sir.
0 is also. So as you can see, let's say, so then what will happen here? Okay, so this, see, so here the value is in up to certain stage, the value is basically in between. If you come to the left of 1, up to certain stage, the value of this function will be in between 0 to 1, right?
Yes, sir.
And after a certain stage, it will go beyond of 1. Okay.
Yeah.
So during that period, actually, what you will have a asymptote here, right?
Yes, sir.
So it will cross like this, right?
Okay.
Because so as you can see, if you come here, it's actually going towards plus infinity, right? So the p of x is going towards plus infinity. So if you take log of p of x, will also go towards plus infinity. Okay. And similarly, the same thing will happen around 2 as well, right? Because if you, so up to certain stage, the value of the p of x will be basically in between 0 to 1, right? So because of that, again we'll get a asymptote here, and again it will go like this. So this will be the graph, some rough graph of this function, log of p. So the thing is, you just need to know you just need to know this graph of this p of x and the root of this polynomial. Okay, so this root of the polynomial, okay, root of this polynomial will give you
the vertical asymptotes.
Yes.
But sir, this brings me to my next question. Like there were some minor changes. I mean the set A and set B. And in the set A, actually, they were taking 1 and like value of 1 and 2. Let's say we are taking, I mean, this same function with some minor changes. So in the set A, it was, I mean, sir, in set A, I mean, in that paper, set A, they were taking point 1 and 2. And the vertical asymptote was something else. Something else means very close to 1 and 2. I mean, something like that.
What is p of x?
So I don't remember the exact, sir. I need to find the question, since there were lots of questions. I mean, question paper in the open notes. But sir, the thing is, it was like log of x square minus 5x plus 6, I guess. I don't exactly remember the question.
Log of?
Kind of like that. Log of x square minus 5x plus 6, I guess. That was the thing. That was the equation. I mean, for one set, I guess. This one. So sir, for either for this expression or some minor changes were there. I mean, with that last part, that minus or plus something like that. So so for first part I have calculated. I was getting like 1 point something for the vertical, for vertical asymptote 1 point something, and for that 3 or something, that I was getting like 3.61 something. I don't exactly remember the values. So they were taking the values 1 and some, I mean the 1 and 3, that point, something like that. And on the next set, they were taking the point value that I got. So I was kind of confused, like how to actually relate to this question. I mean, this kind of question.
No, I still actually I don't understand. Okay, so until unless I don't see the question completely, I can't comment. So so basically I said, right, so when you have a question like this is how you should answer. Okay, it doesn't matter what this polynomial p of x is. Okay, if it is, certainly if it is a quadratic polynomial, then you draw even it doesn't matter if it is a quadratic polynomial. Suppose it's a cubic polynomial or 5-degree polynomial, and you know all the roots of this polynomial. You first try to draw the graph of p of x, and accordingly all the roots of this p of x, okay, will, and will basically will give you some horizontal, not horizontal, some vertical asymptote. So that is the, in some sense, that is the vague idea of solving this type of question. I don't know if so what sort of modification.
Yes, sir. I found the question actually.
Yes, tell me.
Okay, so sir, it was f of x log base 1.5.
F of x
log base, I mean f of x equals to log base 1.5. And in the value it was x square minus 5x plus 5.
Okay, so nothing is there. Same argument. It's, see, this base is basically what? This base is greater than 1, right?
Yes, sir.
So you will get a graph like this. Okay.
Yes, sir.
So the thing is, so it's depend, as I said, it's depend on the base as well, right? See, whatever I have drawn here, okay,
yeah.
This is for base greater than 1, right?
Yes.
So when you have a base greater than 1, you get a graph like this, right?
Yes,
this is basically 0, this is basically 1, right?
1, yeah.
This is basically log ax when base, if
base a is greater than 1.
Greater than 1, right? So here, as you can see, so this is in some sense in this region, okay, in this region, this parabola is basically in between 0 to 1, right?
Yeah.
And similarly in this region, this parabola is basically greater than in between 0 to 1. So similarly this graph will change if you change the base. So again, it's depend on the base as well.
Okay. But sir, the thing is, I mean, as far I've understood this log, I mean, the base is actually the amplification factor, right? I mean, how much it would go up on the y-axis, right? If we take like 2.5, I mean, the stretch would be more on the y-axis. I mean, more above the above x-axis, right?
If the base is less than 1, then what will be the graph of this polynomial? If suppose you take log ax where a is less than 1.
So it would come from top to bottom. I mean, not this one, this greater than 1. It would be the inverted one.
In what sense? So you are saying this will be what? So are you saying this? What will be the graph? First tell me.
Yes, sir.
You are saying this one.
Yeah.
So this is
my 1.
This is your 1, right?
Yeah.
So again, like if this is the graph, okay, let me just check whether this is the graph. So it's so basically it's saying the power y equal to x. Okay. So yeah. And if it is negative, yeah. So again, like if you have a graph like this, okay, then you have to draw the graph accordingly. Then you have to see how this will behave in that case as well. Okay. So
Okay.
So do you want me to draw a case for this negative case?
Yes, sir, yes, sir, yes, sir. That would be kind of helpful.
Yeah, just a minute. Okay, so let's say you consider this function, right? This function. Okay.
Okay.
So suppose you have a graph log, let's say log 0.5 x minus 1 times x minus, right?
Okay.
So again, this is the graph, right?
Yeah, for the
Polynomial
polynomial.
P of x.
Yeah.
So you know that what in some sense you know that in this region this 0 to 1, okay, this is actually going towards plus infinity, right?
Yes, sir.
And again it's basically coming down, right?
Yes, sir.
So so what actually now you'll do, you try, so this is your domain, right? This part is not in your domain of your function,
like 1 to 2. Yeah.
Yeah, this part is not in your domain of the function. So this one is not here. 1, 2 is not here, right? So, and again, so then so again the same thing will happen, right? You will have two
vertical asymptotes.
Correct. So this is one, and this is one.
2 at 1. Yeah.
Yeah. So now what will happen? So in this region, okay. So in this region, what will happen? So in between two, so when this polynomial is basically in between 0 to 1, okay, what will happen now?
So it will come from the top and it will go on the left. I mean, coming from the top, it will create an inverted L around the asymptote. Around the 2. Yeah, that's an L kind of stuff. Yeah, like that.
Correct.
Yeah.
So what will happen here again?
So it would be the replica of the curve that you have drawn on the right side.
Yeah. So correct. So again, if you'll take this one, it will go like,
it will pass, yeah, like that.
Right.
Yeah.
So again, like as I said, it's depend on the base. Okay. So but there is not much difference. Okay. If you know these two graphs, okay, if you know these two graphs, then you can draw this graph also. So if your base is greater than 1, then you will have something like this. And the base is less than 1, you will have something like this.
Okay, so this is clear. Sir, I have another question. That is like, let's say the base is greater than 1, and I have like one log is positive and one log is negative. Negative means the minus is ahead of log. Let's say you have taken the log. Let's say it's the base. I mean the natural log, or maybe with base 10. It could be anything like greater than 1. So x minus 1, x minus 2. So if I take the minus, I mean, if, yeah, like that, yeah. So if that is my given function, so the graph would be the same graph that you have drawn right now, right?
No. How come? It will be minus of this graph, right? If this is AB, okay, then instead of AB, what you will get? A of minus B.
Minus
right?
B, yeah.
So
Yeah,
this point should come here, right?
Okay.
So you will have a graph like this.
Okay, so the graph that you have drawn for the less, I mean, the base less than 1. So that would be my, like, that would be the same. Like this.
Yeah, kind of. Yeah, you will get a graph which is basically this log base where the
0.5.
base is base is less than 1.
Okay, sir. Got it, sir.
So for the same graph, if the parabola is downward,
Then again you have to do it accordingly. It's if the parabola is downward, basically you don't have much. Okay, you are basically in a restricted domain. It's basically you'll have something like this. So suppose you take this parabola. Then the domain of this function is precisely 1 comma 1 comma. Okay, this will be the domain of this function. Okay, and yeah, so in some sense, you will have certainly you will have 2 asymptotes. Okay, so because it's going in between this 0 to 1, you will get, because of this 0 to 1, you will get 1 asymptote, and also because of this 0 to 1, you will get 1 more asymptote. But that is sort of compact domain. Okay, so here you sort of have a unbounded domain. So here you have just a compact domain.
Okay.
So again, like this graph is certainly dependent on the base of this log function.
Okay, sir. So now I know what mistake I did over there. Okay, sir. Got it, sir.
Okay, fine.
Okay. Thank you, sir.
Yeah, thanks. No.
thank you.
Yeah.